So what we have, this is way too big, and hopefully it'll fit. It's an element of, okay, so we have B is an element of alpha, and, whoops, gamma, element of beta, therefore, oh, there was no space. Okay, so, oh, and this is, again, just to be clear, this isn't for everything, this is for A, such that A is an ordinal. Right? For any ordinal, it is the case that, sorry, I thought I was up here there for a second, it's just a bald guy. Hopefully he's not watching this. It's not bald, it's shaved, it's very chic. So we have beta is an element of alpha, and gamma is an element of beta, therefore, gamma is an element of alpha. So, for any of you who remember your first algebra class ever, it's a basic law of the transitive property, right? If B is an element of A and gamma is an element of B, right? B functions here as the transitive fulcrum, as it were, such that gamma is an element of A. And of course, this makes sense because it's an ordinal, and every part is belongs. Or every part is included. Every part belongs, and every element is included. That's the. So, is there any questions about this rigorous formulation, or anything immediately to add on it? Okay. Then we're going to go on to what he does with this. So Badiou outlines the concept of larger and smaller, and it's important to note that these are always in quotes. And the reason why is because we don't yet have the rigorous formulation of them, which comes, as you all should know, a little later in the chapter. An element is smaller if it both belongs and is included in another set. So it has to both belong and include. And the reason why this would entail that it's smaller is because there would have to be a minimal, right, a minimality of that set to which the smaller set belongs, which then includes some element or has some element which is not in that smaller set. Now, of course, the objection might be raised, well, what if that set includes everything if the smaller set includes everything that that larger set includes, right? Wouldn't this be a problem? Well, no, it's not a problem, or rather, by the axiom of extensionality, right, they would be the same sets. But this isn't a problem because, right, sets are not allowed to belong to themselves. So A couldn't be smaller than A because, right, A belonging to itself is ruled out, at least provisionally for now, by the axioms. So does that everyone understand, one, what the concept of smaller is, and two, why it's not an inconsistent concept? Anyone have anything to add? Feel free to, again, jump in at any point. Okay, so now Badiou outlines the concept of a property in a general, or of a property in general and minimality in specificities. So this, I believe, is our first formal introduction of a property. And I mean, just going back, what is a property? A property is not something that brings things into existence. It is a way of sorting already existing sets. So I cannot stress that enough. It's a way of sorting elements of already existing sets. So the main term that he's going to use is going to be phi. Psi. Sorry, phi is right now. No, that's not true. Anyway, I'm gonna just stop. Phi is the perfusis. That, you know, that should be in a children's book. Phi is perfusis. Psi, sorry. Okay, so what we have psi, this is going to stand for formula, right? So I'm going to use a couple terms just so we can stay on the same page. Psi, language is the term Badiou most frequently uses, but also it could be theorem, and also it could be formula, and also it could be function. So if I use any of those terms, they're basically usable interchangeably.
Did you say theorem?
Did I say theorem? Oh, okay.
Yeah.
No, sorry.
Theorem would not be included.
No, theorem is what's generated
Yeah. Okay.
out of this. Sorry.
Just making sure.
Again.
Function,
Function, language,
Formula.
formula,
not
not theorem. Okay, so with this we have Badiou asserts that for every natural order there exists some minimal property or halting point such that it is quote unquote below the property that below that element that property does not exist. Okay, so he gives us a rigorous formulation of this,
Though he's not going to prove it till meditation 18.
where we get the good old axiom of foundation. This isn't proven, and actually, I guess in a certain sense, it's not even provable.
From the axioms it is.
Well, no, I mean that's the thing is it requires an axiomatic decision. Okay, so let's give us some psi here.
Was there a better black marker that was even used? That was pretty haggard.
It is pretty haggard. Sandy haggard.
So Hagar?
I know, but that doesn't work with what you said. So.
Dan Hagar?
And Hagar, yeah. Wow, holy hell, this one's a lot better. I don't know what I was
I
thinking.
suppose you should use that marker.
I propose lecturer's choice. If you have to squint, so much the better.
I'm gonna go with general will. People decide.
Uh-huh. Also, is this universalizable for me as well?
We're not doing
Sure.
Rousseau for 2 weeks here still.
You get public use of reason, but also you're a private function right now.
That's what you think.
Oh, Rousseau's not till way later.
Yeah. Good old politics.
Part 7. Can't call general will until part 7.
Oh, goodness. What? Okay, so what do we have here? Okay, so we have, for the psi of alpha, there exists some beta such that the psi of beta and the gamma is an element of beta, that it is not the case that there is a psi of gamma.
You should write that there is psi of alpha. I don't see alpha. At the very beginning.
I don't see your mom.
Yeah, she's not here.
Okay, good.
Set up my mom in this room.
We always see
That's
that.
it.
What's that? Okay, so what does this mean? It seems pretty abstract, but then again it's mathematics, so that's probably definitionally true. It's actually really simple, and actually this is for A,
Yeah, you should write the A.
or alpha, there we go.
Well, no, this is a relation of implication at the end.
Yeah.
Right, if there's psi of alpha,
Yeah.
then
I'm trying to
there's
say
Right. But this isn't universal. Or, well, yeah.
Yeah, this is universal.
There exists for A, right?
The way it's written is it just says psi of alpha.
Oh, it doesn't have
Implies. So
Implies.
if there is a psi of alpha.
Right, okay.
But yeah, so
Well, I mean, that's why I'm putting the A there, is because there has to be an A for this to follow. Right, there has to be an A. You know
No.
what, we'll just go through it.
no, this is for all alpha. This is a universal statement.
Okay, so in any case, for alpha,
Is that an alpha?
there exists some beta, right, so this is going to be an element of alpha, that there is a function of beta out of, right, the functions of alpha, and that gamma is an element of beta, so that below this, there's a gamma, such that phi is not an element of gamma. So kind of what we got going on here is we got a set of alpha of which we have an element of beta, of which we have an element gamma. Okay? So this is the basic structure. But now we introduce something else, right? Which is we introduce a formula. So this formula, or it should be on the other side. So this formula sorts A, which actually is what gives us this set of B, right? But what happens is there is another set in which is generated, which does not hold this property. So for B, there could be any number of deltas, any number of yodas, thinking of other, I mean delta is usually where it ends. Right, there could be any number of deltas for beta that have psi, right, that have this formula. But the important thing is there exists for beta some element that doesn't, no.
You mean alpha? There
Right.
could be any number of deltas beneath alpha, but beta is the minimal.
Oh.
Because there's
no, oh, right.
Okay.
No, okay, sorry, I was thinking of gamma as the minimal element.
Right, beta's the minimal.
Yeah.